Hello everyone, let's start with this lesson. Signal and linear systems, time domain analysis module for discrete systems. Hello, we begin part 5 today. The second content is the mathematical model of LTI discrete system. In this part, we mainly introduce three aspects of the content. First, linear time invariant discrete system. Second, the difference equation is derived from the practical problem. The third part introduces the characteristics of difference equation. The first thing, let's introduce linear time invariant LTI discrete systems. It has two properties. The first one is linear. That is, as shown in the figure, when the input excites x1 of the k acting on the system alone, the response is y1 of the k. The response of x2 of the k to the system is y2 of the k. So, when the excitation becomes c1 times x1 of the k plus c2 times x2 of the k, the response is going to be c1 times y1 plus c2 times y2. That is, two incentives act on the system alone. The resulting response is in the form of its linear weighted sum. To describe, it satisfies uniformity and additivity. So, how does time invariance manifest itself as shown in the figure when the input excitation is x of the k acting alone on the LTI discrete system? The response is y of the k. When the input excitation moves n units to the right, the response to the system has the same shift. So this is what we call time invariance. The systems described in this section are all LTI discrete systems. So, model of LTI discrete system. How is the difference equation set up? Let's look at an example. Y of the k represents the population of a country in year k, where the birth rate is A and the death rate is B. Let's say that the net increase in immigration is y of the k. So the total population of this country in year k plus 1 is the population in year k plus the number of births minus the number of deaths plus a net increase in foreign migration. So, this is going to be the population in year k plus 1. We call such an expression a difference equation. So, what are the characteristics of difference equations? It is mainly the following several aspects. Firstly, as you can see from the example, the case value of the output sequence of the difference equation, not only determined by the input sample value. At the same time, it also depends on the previous output value. Each output value must be retained in turn. Second, the order of the difference equation. The difference between the highest and lowest ordinal numbers of the variables in the difference equation is of order. If the nth output of a difference equation depends on the previous output and input values, then the difference equation describing it is of several orders. The general formula of the difference equation. It is generally expressed in such a form. The left-hand side of the difference equation is in terms of the response, a form of linear combination. The right-hand side is usually a form of a linear combination of excitations. What else do difference equations have characteristic? In general, the familiar differential equation of the continuous system can be approximated by a difference equation. Differential equations we can call exact solutions. What about the difference equation? It is an approximate solution. At the same time, the difference equation describes the LTI discrete system. Between its input and output, there is a corresponding relation with the corresponding block diagram of the system. We have mentioned this in the preface. You can recall that. Thanks. That's all for today. Thank you.